Good morning and good afternoon, everyone. I'm Chris Spinagle from the Warning Decision Training Division. Along with me is Jill Hardy, also from WDTD. I'd like to welcome you to our 10th installment of our Revival the Storm of the Month series. Today's presentation comes to you from the National Weather Service office in San Antonio, Texas. Our presenter is Aaron Treadway, who will be presenting using MRMS FLASH version 12 in flash flood warning operations. And with all that being said, Aaron, go ahead. The floor is yours, so take it away.
Awesome. Thank you, Chris, and thank you, Jill, for having me. I just wanted to talk about our office and how we have used Flash here for the last several years. So just a quick outline. I do want to run through that and then talk about the big difference between version 12 and the previous version, version 11, which is related to a hail cap in the product. Then really quickly overview Flash for some of you who may not be that familiar with it, and then go through two different cases, one pre our knowledge of this hail cap issue and one after the case, and show you the big differences in the data between version 11 and version 12 of MRMS Flash. And then lastly, go through some of those resources really quick that I have included. So our office has actually been using Flash data for about 5 years now. This rewinds all the way back to Jared Allen, who is the WCM of the Cheyenne, Wyoming office. When he was here as a journey and a lead, he went to the Hydro HWT, and then very soon after that, we actually got some of the first Flash data going live into AWIPS into a WFO at our office. A year later, I went to the HWT, and from there, it sort of snowballed into us doing local studies about how Flash can actually help us do better river forecasting. But eventually, because of our usage of it, we discovered this kind of difference in these version 11 and version 12 products, and ultimately helped Southern Region and all the regions get this version 12 of MRMS Flash going into WFOs before the full version 12 MRMS gets rolled out, which should happen later this year. So what's the difference we found is that basically with the older version of MRMS, it caps the instantaneous precip rate at 2.12 inches per hour. And this instantaneous precip rate that comes out of MRMS is actually the heart and soul of these Flash products. Most of them that we'll talk about in a second use this instantaneous precip rate to make their determination. So errors in this can actually go down the line into some of the Flash products. So we noticed during an event in 2019 that maybe some of these Flash values were a little bit off, a little bit underdone. So we started conversations with Steve from OU, who runs basically the MRMS side of things, and JJ Gurley, basically the Flash developer from NSSL. And we eventually got Southern Region to start sending the new Flash data over the LDM by the late summer last year. And that's now available to everybody. If you're not in Southern Region, all of the regions now have this ability. So if you were a big user of Flash data, you can actually contact your region and start get that data into your WFO ahead of time. So what is this really all about? Well, it's not just the hail cap. It actually goes back to the rainfall rates that are used in the product. So in version 12 of MRMS, it no longer bases the ZR relationships that it uses to calculate rainfall off of the precipitation class. So in version 11, as you see in the bottom table, actually a table that Joe created, you have that cap at 2.1 inches per hour. Well, if you go to now version 12, you now have different rainfall, basically rate caps that use specific attenuation, specific differential phase, and even other relationships to determine that rainfall rate. So not only did the cap increase from 2.1 to 5.9, but it's basically a smarter algorithm and a lot more in-depth logic to determine exactly what rainfall rates are used in these MRMS products. And it all goes back to that KDP, to that dual pole basis here. So going from legacy back with MRMS version 11 to now the dual pole-ish data with version 12. So here's an example, actually just from the other day. This was a very, very outer band of Marco, I believe, that we captured on Monday. So if you look at the top, those are the precipitation flags. And you can notice from version 11 on the left and version 12 on the right that those hail areas are about the same. There are a couple of pixels difference here and there, but in general, they're about the same. But if you look then at the bottom, the actual rainfall rate, it may be a little bit hard to tell, but there's a lot more detail in that version 12 rainfall rate, especially on this top one that you can see a lot darker reds here that aren't evident in the version 11. This middle one is a lot more blocky where there's a lot more detail in the version 12. And so what's actually going on behind the scenes? And if we look at that, this is now for the version 12. Now that's the new dual pole flag, and you can see the different, the A's are the attenuation, and then you have the KDP's one as well. And so where you have those higher rainfall rates, it's now using that KDP and that mixture of A and KDP to determine these higher rainfall rates. So it's not just purely that capping of 2.12 inches per hour, but it's now also a totally different way of figuring out those rainfall rates. And ultimately, at the end of the day, it just gets you a better product, both in MRMS and consequentially in MRMS Flash. So really quickly, these are just 4 stock images from the flash.ou.edu webpage to explain the different products. The 2 on the left are Crest Streamflow and Crest Unit Streamflow considerations. And basically what those do is they determine basically how much overland flow is happening from the rainfall that's going. So unit streamflow takes into account a whole area, so maybe an urban area, where just maximum streamflow by itself actually includes all of the rivers and the streams in those areas. On the right, you have 2 products. One is QPE to flash flood guidance ratio, which you may be familiar with from FFMP, and then also precipitation return periods as well, which now do include Texas. In this image, it's an older one from 5 years ago, but now with all the new return periods and the new studies that have been done, Texas is included in those as well. So those are the 4 main products used for MRMS Flash. Okay, so now jumping into the 2 cases. The first one is August 12th, 2018. So we're going to set the stage. I was actually the warning forecaster, and this is about 5 a.m. in the morning on a mid-shift. Man, I've had a tough night, and we really weren't expecting that heavy of a rainfall, but we started getting some training out over the hill country, our more rural, more hilly terrain here in the Austin, San Antonio WFO. And I started to look at Flash because I was accustomed to it. And this is the initial data for the time that I issued the flood advisory. And you do start to see some peaks of QPE to flash flood guidance, even the ARI. And you can also already see that difference between version 12 on the right, which is the newer data presenting the higher values, and version 11 on the left, which is the older data with much lower values. So that's already one big takeaway, is because of these new schemes that version 12 uses, it's actually getting us higher data, but in essence, better data, because again, it's no longer capped at that 2.1 inches per hour. It's able to take in those higher rainfall rates that we get a lot of the time around here. So this is my first trigger point from when I issued the flood advisory about 1030Z. Again, this is basically the same values. Already getting about estimated 1.5 to about 3 inches of rainfall out of this. And if I had looped this, you would actually see that precipitation is fairly stable training over one area. So one quick thing that I wanted to point out here, which I'll talk again in the resources, is a really quick reference guide that Scott Lincoln out of WFO Chicago developed to look at things like 1 hour rainfall rate, QPE to flash flood guidance ratio, ARI, and stream flow to gauge what product you issue. And from this, it really does fit into that flood advisory realm. Beyond that, now let's get forward to the time that I actually issued the original flash flood warning. So I had kind of gotten a little bit distracted, admittedly, doing the taps, doing other things to rack up the shift. And when I turned back to Flash, I was presented with this. And again, I was looking at the images on the left, the older data, but really regardless of which you look at, we're now at 200% in some pixels of QPE to flash flood guidance ratio, ARIs of over 100 to 150 years. And those values are even higher for version 12. And so I was like, oh my gosh, got to get that flash flood warning out. So this again was right around 12D, right at shift change for us. But the thing that I did is after the event, I actually went back and did a lot of post-analysis on this event. We had several things come up from our staff about rainfall rates, using our DFX radar, which was closer, our radar, which is further to the east, and then also the differences in the flash data. So doing post-analysis on it, I actually came up with that the better flash flood warning point would have been about 40 minutes before I actually pulled the trigger. So these are the better values, a little bit lower QPE to flash flood guidance ratio, but still over 100%. And again, this stuff is training over the same area. And basically I was like, this is kind of the better place. Now, ultimately at the end of the day, it worked out because my warning still gave about an hour of lead time before our first call from the Uvalde County Sheriff, and an hour and a half from when the flood wave along the Nueces River actually hit two different campgrounds. So you can see the snippet on the bottom of a tweet that we issued showing the really big difference in the Nueces River from the ultimately 8 inches of rainfall that fell. And on the right, an article about some of these campers that were caught off guard. Well, one of the two were. The other campground actually got our WIA. This was before we changed the rules for WIA and flash flood warnings. But they got our WIA that I issued and actually got all their campers up and out, and they had no issues at this other part. So we went out, talked to them, our WCM and I, and got all this information. So this is a really big success story for WIA, especially in a rural area. And we didn't know either of these two campgrounds existed even before this. But a lot of these more rural rivers actually have these campgrounds because people do enjoy tubing along them. Okay, so let's skip now to the second event, which is now after we figured out this issue. We now have both version 11 and version 12 of MRMS Flash going into our office. And now you can kind of see the differences between the MRMS values on the left of the old and the new version and our local radar. So this is looking again at that very critical instantaneous precip rate product. On the left, you can see those blocky green areas on the bottom, and that again is that cap, that 2.12 inches of rain per hour. And if you look on the top, the new version has a lot higher values, 4s and 5s and 6 inches an hour in terms of that rainfall rate. And those are in line with the rainfall rates that we were getting estimated out of KEWX, our New Braunfels radar, and the Granger radar, KGRK. So it's just showing that, hey, this new version of MRMS is a lot more in line with these instantaneous precip rates with data from our raw radar. Okay, so this is now what the data looks like in AWIPS compared. So on the left side, you have the version 12, and on the right side, you have version 11 of those three main products that we use in Flash: the unit stream flow, the return period, and the QPE to flash flood guidance ratio. And again, the big things that jump out here are the version 12 are a lot higher, but you can still see the maximum areas, and they correspond to each other fairly well, one here in Hays County, one in northern Bexar County that we'll talk about. You can also notice that the response in some of the big rivers like the Colorado and the Guadalupe is a lot more evident in the version 12. So again, it's just saying that, hey, this is more accurate of what's going on and presenting us a better representation in Flash version 12 of the actual rainfall and the actual impacts on the ground than what we had gotten in version 11. So it really all comes down to trusting the data. So again, now here on the bottom are your comparisons of the two versions of MRMS, specifically looking at the return period. On the top, you have our KEWX radar, legacy, and dual pole storm total precip. It's all about trusting the data that you've got. And so this goes back to, is MRMS representing things really well? Because if it is, then that translates to good flash data. You know, are your raw radars presenting it well? And that takes looking at these different radar products and going back to your observations, to your networks of rain gauges, which thankfully we have a pretty good network here in South Central Texas, to compare all of the values that you're getting. And for this event in late October, actually everything did fairly well. Was within about an inch of observations, both the raw radar products and the MRMS themselves. Now looking at the warning points for this second event, the flood advisory happened just around 1Z. So you've got now a 6-panel, which we're going to talk about more. Basically the standard 6-panel we use now in our office when looking at MRMS Flash. You've got the composite reflectivity and the 1-hour precip on the top, and then the 4 flash variables on the bottom. So you see things starting to peg out in the QPE to flash flood guidance ratio, have some values that are approaching 75%. You've got some higher values of unit stream flow and some return periods of about 25 years. And this is where local knowledge comes into play, going, hey, this area of San Antonio, which is the north area of the city, kind of always floods. You get a couple inches of rain, you're going to get some streets that flood. It is very much a flood advisory type flooding situation here. Well, if we fast forward an hour, things look drastically different. So basically the rain is still almost exactly where it was. We've got now 1-hour rainfall rates of 2.5 to 3 inches of rain. And then things like the unit stream flow are now very high, which makes sense because we now have QPE to flash flood guidance ratios 150 to 200%. and ARI is now approaching 100 to 150 years. So this is the point that I was like, nope, it's flash flood warning time. So these are both events, again, that I worked and was able to use this data and keep these events in the back of my mind to really show the improvements that version 12 has made. So one big thing that I did want to point out is related to the QPE to flash flood guidance ratio. So as this loops through, at the end of the loop, you'll notice that big jump in max QPE to flash flood guidance ratio. That is the local RFC, which takes the flash flood guidance product and determines making an update to that flash flood guidance product. So flash is going, well, the ratio was good when it was 4 inches in an hour or 4 inches in a certain period, but now that it's rained so much, the flash flood guidance is lower, maybe it's a ½ an inch. And what that does is when they make that change, if there's still precipitation ongoing or it's towards the tail end of the event like it was in this case, it creates that jump in the product. So that's one thing to look out for and kind of know in the back of your mind that that's not some big massive flooding that just happened, but that's actually a change in the background in that flash flood guidance product that facilitates that big jump. And that's still there. That was there in version 11. It's still there in version 12. So talking about some of those resources, and again, it's in the handout section of the GoToWebinar, and the WDTD folks are going to share the link as well. But I've got a lot of cool websites in there, a lot of the research that I talked about early on in the presentation. And one of the things when I presented some of this for Southern Region, the question that I got was, well, how do I get all of this into AWIPS and how do I organize it all? And that's where the 6th panel that I've used came from. And it's got other things in the perspective of kind of breaking down some of the other products into various 4 panels. But I've got links to this in the perspective. So really all you have to do is you or your ITO grab it. And as long as you're getting the data in the office, it's going to be ready to go for you. This is also Scott Lincoln's reference guide again. He has done presentations on this, and those links are in that reference guide. Again, this is for WFO Chicago specifically and research that they did there. It's fairly representative even in our Flash Flood Alley area of South Central Texas. But again, take this for your specific area and maybe make some adjustments and see what really works for you, because there has been noted throughout the life of Flash differences from WFO to WFO, differences in more rural areas, more urban areas. That's just a thing to watch out for, but it's a good starting point for sure. Other things, the flash.ou.edu website. So all of the data, while it can be in AWIPS, is also online for you to look at. You know, if you're somewhere in the Northeast or Northwest and want to watch the flash data as Hurricane Laura makes landfall along Texas and Louisiana, these are great resources to go to here. And then also other things like the Hydro Viewer online. So this is Danny Gant out of the Morristown office has basically put a lot of this now on an ArcGIS online map, including the ARIs and the flash flood guidance ratio for anywhere in the country. So this is another tool that you can have on the PC side to pull up some of these things and monitor them. It's just another tool for flash flood forecasting that you can have as well. So really the bottom line, so to summarize everything, I remember from my RAC days to things like Bill and Mesh, don't use them as the gold standard, but treat them as tools that point you towards the impact. Use Flash the exact same way. It's something to say, hey, this is probably what's going on. These are the areas that I definitely need to look at. Something when it comes to determining your polygon coverage, I mean, you can use things like the flash flood guidance ratio or the ARIs. Really, that crest stream flow helps a lot because it also starts taking into account the rivers that the water is flowing into, so you can start drawing those polygons downriver to take into account those impacts as well. So I've been hand drawing those in the new hazard services. Definitely always apply your local knowledge. You can use QPE to flash flood guidance ratio as an alternative to FFMP. I think we've only got 2 or 3 forecasters here at our office still using FFMP while most now use Flash. But again, that goes back to being able to trust the sources. And in FFMP, you can still choose where you get that data from. So that's still one plus of FFMP. The Flash now is better because of that dual pole basis, because of the different rainfall rates. But one thing, you may need to recalibrate yourself in your office to a faster trigger due to those higher values that are now being presented, those more accurate values. Always do good post-storm analysis. Go back and figure out what went wrong, what went right, what in the data can you look at next time to make things better. And there is, again, still that jump in the QPE to flash flood guidance ratio that's still around for when the flash flood guidance updates. So that's one big caveat to using these Flash products. With that, I want to thank everybody for your time, and I'll open the floor for questions. That's my email. If you have specific questions, feel free to email me or tweet me. This presentation, the link sheet, and everything is actually on our office's radar program page. I'm our radar focal point. So if you don't want to get the information from WDTD, it's also always there, and anybody in NOAA can get to our Google site. So it's also there as a reference, in addition to the stuff that WDTD will send out. So with that, I'll open the floor to questions. Thank you all for listening.
All right, great. Thank you very much, Aaron, for the great presentation, and have a good rest of your day.